Hey everyone, welcome to class. In this particular lecture, we're going to be talking about the powerful aspect of descriptive statistics or summary statistics, how we can use that to then take our research questions and our research hypotheses that we've kind of drawn earlier on in the quarter or in the semester for you all in this case. And we're going to take them and transition them into being able to summarize them in a palatable way to show other researchers or give presentations on what's going on in your data. It allows you to take these big data sets, right, these big sheets, right, and condense them into more palatable information so that you can then kind of start to see some patterns and convey what's happening in your data in an easier way. So again, we've done the first two parts of the scientific method, right? We're moving into the testing and analysis phase. So we've already asked our research question, we've already kind of derived our hypotheses, and we're moving into this moment where we're either testing, gathering our data, which we're already going to have in this case, and then moving into analysis. So when we have quantitative data, we need to analyze it in a way that makes sense. And we do this through statistics, and we start with descriptive statistics. It's one of the kind of easiest, most accessible branches of stats. So describing the data is always going to be your first step. It gives an outline of the kind of data that you have so that any audience knows kind of what you're working with. It also gives you an idea of what sort of statistical tests are appropriate later on. If you don't do a good job of your descriptive statistics and you don't do a good job of analyzing the kind of data that you have, then eventually you can get to a point where you do an inappropriate statistical test based on the sort of data that you have. And so it's really important to understand your data at the most basic level before you do any sort of fancy testing. So really, I want you guys to think about the idea of descriptive statistics as being summarizing, thinking about what your audience can and can't see. You as the researcher are able to see your data set. You're able to see and play and toggle through your columns and your rows, and you can look and kind of understand what's happening with your data set right off the bat. The audience that's either reading your paper or watching your presentation is not inherently going to know that, right? If you're giving a research talk, they're not going to be able to see your data set on the fly. So one of the things you can do is show them the kind of contours of your data through descriptive statistics. We'll use things like averages or means and measures of centrality and spread to show others right off the gate. We'll use a single number to kind of represent our broader numbers in order to summarize and make things a little bit more palatable and give people or the audience a solid understanding of the sort of data that we're working with. So in order to properly describe, we always need to start with the level of measurement and understanding what sort of level of measurement we're talking about. In this case, we always are kind of starting with the same framework that we've been talking about, where you either have nominal or ordinal or interval ratio, and that special case of binary, right? All of this frames what sorts of measures of centrality and spread, which we'll talk about a little bit more concretely later. They change what kinds of descriptive statistics you can use. So in order to do descriptive statistics, you need to know what kind of level of measurement you have. We also are doing descriptive statistics at the baseline to establish causality, right? So that's one of our main goals as researchers, is to understand these phenomena in the world and to be able to kind of concretely link the phenomena in our hypotheses and in our research questions. And so we need to be able to be clear with others about what kind of data we have, what are the strengths and limitations of it. And data is complicated, right? There's obviously usually a lot of it, and you have to find ways to condense that and summarize down. So you have to be clear with what you have. And so descriptive statistics are essential for doing this thing, which is starting to establish causality. So think again, the researcher that you're maybe giving a presentation to or is reading your paper can't see your columns or rows in the same way you can. So you have to summarize those columns or those rows as single numbers. So we're going to think about the ways that we can summarize our columns in particular as single numbers moving forward. So say we wanted to study the relationship between study time, which is on our x-axis. This is our independent variable, and our y-axis, which is going to be seeing if it's related to midterm marks or grades. And so just on a descriptive level, we're plotting our data, we're kind of getting a sense. One of the ways that you could kind of start to kind of summarize what's happening in your data is through this tool of visualization. So we'll learn how to do this moving forward. And we see that as on the x-axis, as study time increases going from 60 to 180, we see that as that person studies more, they get higher grades on average, right? So those who studied less in the 50, 60-minute range got pretty low grades. In the 60 to 90 minutes, they got pretty low grades between like 50 and 70, right? But the second you start to get out to 150, 180 minutes, we see that people are in the 90, sort of 80s to 90s range. So this is important to show that we can start to visualize this sort of relationship more concretely, because we can look at the maybe average amount of study time or the average midterm grade. Those will kind of give us some ideas of central tendency for those particular variables. It also will help us understand things like outliers, or the dot that's marked in red, which are variables that deviate from the norm. So this person who studied 120 minutes, if they followed the pattern of the rest of the group, they probably would have got a mid to high 80%, right? At the lowest 80. But there was a deviation, right? And so we can study that and try to understand that. So our descriptive statistics can help us see that more clearly. And they also can give us the sort of measures of centrality, or better ways to understand the contours of the data for our dependent and independent variables.